Swayam Prabha. Digital India. Educated India.
Hi dear friends, welcome to this third lecture of Module 9 on Engineering Geological Investigation for Roads and Highways, Bridges and Building Foundations. In previous lectures, we have discussed about roads, pavement, stress distribution in road structure, engineering geological investigation for new road alignment or highway alignment, and some specific study about the hilly roads. Now in these lectures we will going to discuss about bridges, classification of bridges and working mechanism. In these lectures we are going to deal with bridges, classification of bridges and mechanism of working of each category of bridges. Regarding this, we are going to cover about introduction related to bridges and then definition of bridges, classification of bridges and working mechanism. Friends, as you know, the bridge structure that spans horizontally between supports whose function is to carry vertical load. Here you can see one view of the carriageway on bridge. The whole load of traffic or this road is transferred vertically to the foundation strata. The prototype bridge is quite simple and two supports holding up a beam is recognized as bridge. For simple concept, we have taken examples from nature. As the vertical load transferred to the strata, therefore strata should be sufficiently strong to withstand with the coming load due to bridge structure as well as traffic load. The spans are generally made as short as possible. Long spans are justified where good foundations are limited, for example over estuaries with deep water or over large ponds and others. All major bridges are built with public money, therefore bridge design that best serve the public interest has a threshold goal like to be efficient, to be economical and as elegant as is safely possible. If we are going to make the longer routes through bridge, it may be costly and creating a lot of problems to society. It may be non-economical, not efficient, or some problems related to support system. If we are going to define bridge, then we can say that a bridge is a structure built to span a physical obstacle such as body of water, such as road or railway or fire zone or swampy area or any forest, etc., without blocking the way underneath. It is carrying a pathway or roadway over a depressions or obstacle like river, like fire zone, like mines, any kinds of struggles, and a bridge connecting one place to another place, one point to another point. The concept of bridge devoted to a structure built to span a valley, road, body of water, or other physical obstacles for the purpose of passing over the obstacles. The first bridge or the concept of bridge derived from nature. So the first kinds of bridges were made by nature itself due to erosion of a rock body up to limited extent, or due to fallen of tree over a stream or over a nala or over a river. Human then begins placing logs or planks across gaps they wanted to cross, and the first kinds of bridges were made by nature itself, become the inspiration behind the construction of bridges. You can see the simple way the wooden logs utilized to cross this water body. Similarly, we have other types. You can see the naturally eroded rocks is going to provide some bridge-like structures, become natural bridge. The forest persons as well as animals can utilize such type of structures. This is taken a view from the Virginia. It is a natural bridge from State Park. Another examples taken from the Monte Verde. Naturally, this tree, fallen branch of tree having some support, and this type of arrangement provides the movement of peoples, animals, forest animals and other from one point to another point. So this is good example. If we are going to see about the bridge and different type of bridges, then we can say that it may be fixed or it may be mobile. Like this type of bridge, the wooden log can be replaced to another as per requirement. Another view, we have some kinds of bridges which can be placed from one place to another place as movable. So if we are going to categorize bridges, we can select certain point to categorize bridges, like based on origin, based on dynamic, it is static or dynamic, means zero dynamism or considerable dynamism of the structure, then based on design and working mechanism, etc. So based on origin, we can easily divide bridges in two categories. One is a natural category of bridges that we have already discussed, due to fallen of tree or due to erosional cavities or opening developed in rocks, or due to spread of branches of some of trees to make the connections from one point to another point. Then man-made bridge based on dynamics, means related to motion, movement and others. The bridges can be divided in two categories: fixed bridges and movable bridges. Fixed bridges can further divided in categories based on design, like beam bridge, truss bridge, arch bridge, cantilever bridge, suspension bridge, cable stay bridge. In movable, we have one famous category of bridge, that is the pontoon bridge. Pontoon bridge generally we utilize as a floating bridge. You can see here the pontoon bridge, a view of pontoon bridge. located nearby the Chunar locality, and nearby one type of bridge is under construction, beam bridge. The platoon bridge is a floating bridge used primarily to cross a river or cross a water body by society, but not invariably for military purpose, because in very early a platoon bridge was constructed in 480 BC by Persian engineers to transport Jerebe's invading army across the Hellespont. Later on, the communities of world have almost banned to use the platoon bridge for such military purposes. Fixed bridges are usually classified on the basis of their geometry and working mechanism, and we have already discussed about beam bridge, truss bridge, arch bridge, suspension bridge, cantilever bridge, and cable stayed bridge. So one by one we are going to discuss. First, classification of bridge depends on the component of bridges. So first we are going to introduce about the different component of bridges or bridge. Broadly, the structure of a bridge can be divided in two categories. First is superstructure. Superstructure is the structures which are going to facilitate the purpose of construction, either in terms of movement of traffic or movement of rollers, motors, trains, etc. So this structure is recognized as superstructure. It serves as a link between two sides of a valley, canyons, or body of water, or fire zone, or mines, or any danger zone. It connects roads and railways at the two terminals and facilitates traffic movement. This upper portion, including this carriageway and others, is recognized as superstructure. However, the supporting structures we are recognizing as substructure. The substructure is going to transmit the superimposed force due to superstructure or superimposed load to the underlying foundation material through support system, and such supports we are recognizing as abutment pillars or piers. The span is the distance between two bridge supports. You can see here, this is the span. You can see here the span 1, span 2 between two supporting pillars is recognized as span. Whether they are column, towers, or the walls of canyons. Beam, it is a rigid iron plate or concrete structure in form of beam utilized for the connecting two terminals of an obstacles like river, like nala, like ponds. Then piers, it is a vertically supporting structure such as pillars and others. You can see these are the piers. In this also you can see these are the piers. Cantilever structure, it is a projecting structure supported only at one end, like a shelf, brackets, or dividing board. Here we are going to put some support that utilize as cantilever, going to provide additional support to the beam structure. Truss, another structure It is rigid frame composed of short straight pieces of jointed iron to form a series of triangles or other stable shape, and generally made up of steel, recognized as prot. So this type of truss is also utilized as component of bridge. First we are going to discuss about beam bridge. As the name indicates, it is a simply beam structure supported by pillars or piers and abutment. It is generally made up of concrete, but some old time the peoples have also utilized iron girders and others to make such type of structure as a beam bridge. It may be of the single span, it may be of the multiple span. Based on the number of span, this type of beam bridge can be divided into category: single beam or single span beam bridge and multi-span beam bridge. You can see here the single span beam bridge. If we are going to consider beam bridge up to this zone only, and if we are going to extend cover all, then it is a multi-span beam bridge. How it works? Regarding the mechanism of working, when any object in form of motors or anything, any traffic, then this beam is under beam loading, where this upper part come under tension, upper part come under compression and lower part come under tension. So beam bridge is the most common bridge form. A beam carries vertical load by the bending. As the beam bridge bends, it undergoes horizontal compression on top, and at the same time the bottom of the beam is subjected to horizontal tension. If this feel compression, then the lower part of this beam is under tension. This is under horizontal compression. The support carrying the load from the beam by compression vertically to the foundation. Whole load come to the foundation strata through piers and foundation pillar. You can see here foundation, abutments and this pillar. This upper portion of this beam bridge is utilized for movement of traffic and recognized as carriageway. This part is recognized as deck. The lower part is recognized as foundation, and the foundation is lying on rock strata, that is recognized as foundation strata. For safety, we generally fence by the wires, regarding as the safety guards wires. You can see here. In this way, we are going to see about the beam bridge. Another type of bridge is a truss bridge. Due to construction of such type of truss structure in form of triangle, in form of a single span truss bridge is like a simple supported beam, because it carries vertical load by the bending. Here the vertical load of the traffic is due to bending of this beam. Provided compression here, the bending lead to compression into chord or horizontal member, tension in bottom chord and either tension, you can see the compression is a partially held by this vertical structure, and this connecting horizontal structure connect to the abutment side. However, this cross linking part is under tension, going to hold this structure under tension. This is under tension, these are under compression, and these are under tension. Trusses are popular because they use a relatively small amount of material to carry relatively large load at lower cost. Next type of bridge is arch bridge. As name indicate, it is in arch shape as a support carrying this deck. It is arch in shape, and in this the two ends of bridge are carried outward, curving to meet the ground on the two sides. Here meet the grounds on two sides. Here two sides recognized as abutment of a valley. Based on the number of arches, each can be divided as a single arch bridge or multiple arch bridge. Multiple arch bridge or single arch bridge. How it works? An arch bridge works by transferring its loads partially into the horizontal thrust resistance by the abutment at either side. The whole load transferred to the abutment to support this structures. Arch foundation must therefore prevent both vertical settling and horizontal sliding. In spite of more complicated foundation design, the structure itself normally requires less material than a beam bridge of the same span. Due to transfer of the load toward the abutment side, therefore, the strata lying below the foundation pillars should be strong and of excellent quality in terms of rock mass classification. In this the overall load carried through this load transfer first through this type of structure to arch, and arch is going to mobilize the whole load towards the abutment side. In another case, एक मिनट इसको मिटा दें, ये सबको मिटा दें. The truss bridge is a simple supported beam because it carries vertical load by bending. The bending leads to compression in top arch. Here top side compression, vertical as well as horizontal is under compression, and either tension in cross zone under tension along with this beam which is held by this vertical feel compression, and this part also compression, this part also compression. In this way, this structure is going to transfer about all the loads of the superstructure to the abutment side or pillar side. The trusses are popular because it utilizes minimum materials for its construction, and as well as it is economical too. Next type of bridge is arch bridge. As the name indicates, it is arch in shape, which are going to support about the load of this deck or beam. If the single arch is present, then it is recognized as a single arch bridge, and if there is more than this two, then it is a double arch bridge or multiple arch bridge. As far as working mechanism is concerned, the load coming on this beam initially try to bend this beam under compression. This compressive load is transferred by this structure to arch structure, and the arch structure is going to transfer whole load to the abutment side. Here all the load mobilized towards the abutment side in this, and finally this abutment side is going to transfer the load to strata. Therefore, in this type of bridge, the whole load transfer toward the abutment. Therefore, the strata associated with abutment or the walls of the valley should be very strong and of excellent category in terms of rock mass quality. Here the arch structure is in supporting situation. On the arch structure, double arch bridge, the beam or deck is located and supported by this abutment pillars and the foundation pillars. Abutment foundations pillars are the piers, and spandrels are connected to the deck with arch structure. The arch bridge, as per principle, transferring its load partially into the horizontal thrust, restrained by the abutment on either side. Here the load is coming on this arch structure, and this arch structure is going to transfer all the load, all the compression load to the pillars associated with arch, and the spindle is under tension to try to counter the balance of the force and resist the bending of such type of deck structure. Next type of bridge is cantilever bridge. It is almost similar to the beam bridge, but due to presence of this cantilever structure here, cantilever structure, this beam is different from the beam supported by simple piers. So in cantilever bridge, the end girders or beams have extended arms to hold a relatively small beam. The two beams of the bridge firmly anchored with the piers. Here you can see firmly anchored with the piers. This beam support another beam, that is the middle deck of traffic support this another beam. So beam number A, beam B, or beam number 1 and 2. So this cantilever arrangement supported one bridge, small piece of bridge, then the another piece of bridge is supported by this cantilever with help of these two pillars. In a cantilever bridge, the total weight is transferred vertically to two piers, mainly this pier and this pier. However, abutment side there is no load. So whole load due to this type of arrangement and division of this beam is going to transfer whole load under compression to throw the piers. Therefore, the strata nearby this piers should be sufficiently strong and of excellent quality. Because the abutment not required any specific type of strata. If the strata nearby this is weak also, then it can be manageable, because the major loads are almost total load transfer through these piers. Therefore, the foundation structure of such piers should be very well designed and able to transfer whole load to strata. Next type of view related to cantilever bridge, you can see here, collected from the Encyclopedia Britannica. A beam is said to be cantilevered when it projects outwards, supported only at one end. Because here this end we are going to see, a cantilever bridge is generally made with 3 span or 2 span is disconnected in this way, of which the outer spans are both anchored down at the shores or abutment side, and the cantilever out over the channel or river to cross. The central span rests on the cantilever arms extending from outer span, and it carries vertical load like a simply supported beam or truss. In this way, you can see this cantilever structure here is under compression, going to transfer whole load to the piers, this type of support pillars, because this type of truss structure is responsible for making this type of connections of the cables and wire under tension. This is under compression, and these are under tension. That is by tension force in the lower chord and the compression in the upper chord, the cantilevers carry their loads by tension in upper chord and compression in lower only. Inner towers carry those forces by compression to the foundation, and the outer tower carry the force by the tension. You can see here compression, these type of structures, and this is under tension. So in this way, the multi-span or 3-span cantilever is working. Next type of bridge is a suspension bridge. As the name indicates, it is in suspension. The same principle here. This whole load is a transfer. This deck is well connected with this type of wire. The deck or traffic way of a suspension bridge is hung by cable that hang from towers. This whole structure is hanged with this type of cables, and the cable is finally attached to this both tower. The cable transfer the weight to the towers, and the towers transfer the weight to the ground. This is under tension, this is under tension, so the compression load is transferred through this tower to the ground due to suspension effect. In a suspension bridge, the stress is transferred vertically to the foundation, but the bridge is anchored with the bedrock or a large concrete block or two sides to provide stability for this type of action. Because it is under tension, so this tension cable is going to pull this abutment pillars toward the up. Therefore, the foundation as well as the strength of this type of abutment pillars should be very strong to balance this type of transfer of compression force to the ground through these pivoted pillars. Another way you can see here the same concept. Here the whole wire is under tension, which are going to transfer same thing under compression. So this zone should be sufficiently strong to bear with the tensional effect developed due to such type of arrangement. Here in previous figure we have attached this wire directly here. However, in this the number of threads or structure is going to hold this structure. Another type of bridge is a cable stay bridge, the principally almost same as suspension bridge. In cable stay bridge, the cable from the towers go directly to the road deck. Here we are going to connect this deck directly to the towers by using different wires or cables. Connection at different points. This beam or deck is connected with different point, and finally all the ends is supported by this vertical pillar type of structure. The tower form the prime load bearing structure and do not require firm anchorage to withstand the horizontal pull of the cable. Here, due to this compression, because it is this structure under loading is going to put the load, so these come under tension, and due to this tension this whole structure is under compression. Through tension, load or stress, this whole structure is going to hold this structure up and going to balance this structure, partially supports through this type of abutment. You can see this view, the same view here explaining the tension and compression. So this whole structure is under compression, going to transfer this compressive load of this deck through tension in cable to this pillar, and this pillar is the medium which are going to transmit all the loads toward the downwards. So this deck as well as pillars are under compression. This portion should be sufficiently strong because this tensional force is going to counter if due to movement of the vehicles and others, if there is any excess in tension, so either going to pull this side up or going to show the breaking of cables or destruction of such type of structure. Friends, we have elaborated about different type of bridges with example of natural bridge up to engineered bridge or design bridge. The material presented here is based on the sources as Engineering Geology written by Gangopadhyay, published through Oxford University Publications, a thick book ranging in page from 1 to 549, and partial supports from the Engineering Geology book written by Well F.G. having page 1 to 551, and textbook of Engineering Geology Kashabulu along with Engineering Geology written by Shiva Bharati Murthy, and then material taken from the Encyclopedia Britannica Inc. and some photographs from the website with acknowledged to the sources mentioned in slide. As far as conclusion is concerned, we have elaborated all the aspects related to classification, different type of breaches, the transfer of the load through different type of structures. We can say that in conclusion, bridge is a structure built to span a valley, road, body of water or fire zone or any type of physical obstacles or other for the purpose of passing over these obstacles or problematic zone. The bridges are fixed or mobile in view of the dynamic state. Sometimes it has provision to open for allowing the ships and others to cross through such type of structure, and sometimes it is solid in nature and not going to show any opening for such type of facilities. A bridge has superstructure and substructures, where superstructure facilitating the movement and the purpose targeted objective. However, the substructure is a supporting structures going to help in transferring the load to the foundation strata. On the basis of uses, the bridges are divided as road bridge, railway bridge, and the bridge utilized for the movement of wild animals, many purposes. But basically we are utilizing as road bridge or railway bridge, and we have number of examples throughout the India. The man-made bridges are classified broadly as beam bridge based on design, beam bridge, arch bridge, cantilever bridge, truss bridge, suspensor bridge, cable stay bridge, etc. Dear friends, in this class we have elaborated about basics of bridges, definition of bridges, classification of bridges based on different parameters like origin, like design, like dynamic state, like usage, etc. For construction of bridges, the foundation strata should be considerably strong as per requirement. Therefore, the engineering geological investigation about the foundation strata or layers are necessary need for successful, timely and economically construction of bridges. So about the engineering geological investigations, material used and geotechnical evaluations we will discuss in our next class. Thank you very much.